Namashivaya. In this video, we're going to see few important name reactions involving alcohols, phenols and ethers. The first reaction is Williamson ether synthesis. It's a nucleophilic substitution reaction. Here, sodium alkoxide reacts with alkyl halide to produce ether. You remove Na plus and X from this, X minus, and you just combine this and this. So you get ether as the final product. You can see some examples. When sodium ethoxide reacts with ethyl bromide, this and this, you combine them and write as a final product, and NaBr is produced as a byproduct. Instead, if you take sodium methoxide, this and this combine to give ethyl methyl ether. This Williamson ether synthesis gives the best results for primary alkyl halides. The drawback with using the secondary and tertiary alkyl halides is the production of elimination product along with substitution product. So it works the best with primary alkyl halides. The next reaction is Kolbe-Schmitt reaction. It's an electrophilic substitution reaction. We take sodium phenoxide as the reactant and we allow it to react with carbon dioxide, and we use slightly elevated temperature and high pressure for this reaction. This introduces carboxylate unit into the benzene ring. The first step will be the production of sodium salicylate. In the next step, this is neutralized and we get carboxylic acid. We already know OH group is an ortho-para directing group. Therefore, the incoming COO minus group gets introduced to ortho and para positions. The ortho will be the major product. This is ortho hydroxy benzoic acid or salicylic acid. So this is called Kolbe-Schmitt reaction. Please remember, it's different from the Kolbe's electrolysis we have already learned. This is a carboxylation reaction by nature, where Kolbe's electrolysis is a decarboxylation reaction. The next reaction is Reimer-Tiemann reaction. It's an electrophilic substitution reaction. Here, phenol reacts with chloroform and sodium hydroxide. The aqueous solution of sodium hydroxide is used normally. This introduces an aldehyde group into the benzene ring. Hydroxyl group is an ortho-para directing group. So, ortho-hydroxybenzaldehyde and para-hydroxybenzaldehyde both will be obtained. However, ortho will be the major product. So, as shown here, ortho-hydroxybenzaldehyde, and this is otherwise called as salicylaldehyde. The next reaction is Gattermann reaction. The reaction is slightly similar to Reimer-Tiemann reaction. That is, you start with phenol, or for that case any benzene ring with the activating group. So here we are considering phenol. So phenol, when it is allowed to react with HCN or HCl, that is hydrogen cyanide or hydrogen chloride, any one of them can be taken in presence of a Lewis acid catalyst like aluminum chloride or zinc chloride. The introduction of aldehyde group happens at ortho and para positions. Ortho will be the major product. So ortho-hydroxybenzaldehyde or a salicylaldehyde will be the final product. This reaction is called as Gattermann reaction. So you can see clearly the reactant and the product, they are same in both these cases, that is Reimer-Tiemann reaction and Gattermann reaction. However, the reagents used are completely different. In case of Gattermann reaction, it is HCN or HCl in presence of a Lewis acid catalyst, whereas here it is chloroform and sodium hydroxide. So with this we complete the named reactions in alcohols, phenols and ethers unit. Thank you. Let's see in the next video. Until then, happy learning.